Hi children, welcome, welcome to another chemistry class. See, today's our discussion is a very simple chapter, the last chapter from the first year topic, environmental chemistry. A few questions from environmental chemistry. Usually one question definitely comes for the exam from the chapter. So what are the possibilities? Let us examine. First question. Which of the following is a sink for carbon monoxide? There are several studies will illustrate or proves. Option 2, the correct answer. Soil microorganisms can act as a sink for carbon monoxide. To a certain extent, the polluted environment can be controlled by the soil microorganisms, and there are several studies concerned. There is a possibility somebody go for a first choice, hemoglobin, reading certain sentences in the NCERT. That's why it is given the first choice. Hemoglobin can adhere with carbon monoxide. Carbon monoxide attached with the hemoglobin, and the bonding is somewhat 300 times stronger than like that. So statement there in the NCERT. Conceiving that idea, there is a great possibility you are answering first choice. Never do that. It is about environmental pollution, which can act as the word sink. Sink means it is a matter of controlling the environmentally polluting component. So CO2 definitely an environmental polluting component, and which can act as a sink for CO means not CO2, CO carbon monoxide means the answer is soil microorganisms. Option 2. Not a greenhouse gas. Not a greenhouse gas. Sulfur dioxide. You know which are all the greenhouse gases? All of you know. Sulfur dioxide is not a greenhouse gas. All others are greenhouse gases. Wrongly matched concentration. Wrongly matched concentration. Iron, aluminium, copper, zinc, cadmium, such a table available in the NCERT. So that data-wise analysis, you must have a picture regarding that. At least try to understand which one is wrong, which one is correct. That's all. Answer is option C. Answer is option C. 4 and 5 are wrong. What is that? Zinc limited value is 5 ppm. Zinc limited value is 5 ppm, that is wrong, and that of cadmium 0.005. Cadmium is 0.005 is the limiting value. Verify with the text. Okay, next. Viable particulate. Viable particulate. Fungi, molds, etc. can be acting as a viable particulate pollutants. Rubber installations of electrical equipment easily perish in an atmosphere of ozone. Rubber is greatly affected by the presence of ozone. There will be cracking and all by oxidation. Pneumoconiosis is caused by option D, suspended particles in air which is of the size less than 1 microns, up to say 5 microns. It can be settling over the nasal canal. Suppose it is less than 1 micron, it will enter into the lungs and there will be scarring of lungs called pneumoconiosis. Again the limiting value, lead, nitrate, fluoride, BOD you know, biological oxygen demand, and the pH of drinking water, maybe the standards. Answer is option A. The allowed limits, maximum allowed limits as per option A. One is P, lead, Pb2+, 50 ppb. So PQRST, straight down matching. PQRST, straight down matching. Lead, nitrate, fluoride ion, BOD value, and pH value. Yes. Next one. Excess of nitrate ion in drinking water causes methemoglobinemia. Hope you remember. Blue baby syndrome. Blue baby syndrome caused by excess nitrate content in the drinking water. You might have heard about. Okay. Next. Blue baby syndrome. The difference between amount of dissolved oxygen in a sample of water saturated with oxygen and that after incubation for a period of BOD. This is how you find out BOD, biological oxygen demand. The purity of water examined by BOD measurement. It is saturated with oxygen and kept for incubation for say 5 days, and then it is taken and we find out how much oxygen utilized for oxidizing the various organic impurities. That is BOD. And if it is done by potassium dichromate or any other chemicals, analyzing both the organic and inorganic impurities, that is called chemical oxygen demand, COD. This is what called as COD. Using potassium dichromate, you can examine the purity concerned with the organic and inorganic impurities present in a sample of water. That is called as COD, chemical oxygen demand. COD. It is more advantageous because it can give you the measure of organic and inorganic impurities, and it can be easily calculated or easily done within a short period of time, which otherwise take a longer period of incubation time. Next. One liter butane burned in 5 liter oxygen. The ratio of CO2 and CO obtained will be. You see, 1 liter butane, 5 liter oxygen is not sufficient for the complete combustion. That means it is going to give you a partial combustion. A partial combustion. You see, 1 liter butane. Suppose you are taking 1 mole butane, which is C4H10 with oxygen. You get 4 carbon dioxide and 5 H2O. You need 6.5 oxygen. You need 6.5 oxygen. What using is 5 liter only. So 1 liter require minimum 6.5 liter. We are using only 5 liter. That means it's going to be incomplete combustion producing both the CO2 and the CO. What will be the ratio of CO-CO2? So, sorry, CO2-CO. That is a question. It can be so balanced. It can be so balanced. You will get 1 mole CO and 3 mole, 1 mole CO2 and 3 mole CO in order to balance on the left hand side, and the answer will be 1:3 ratio. 1:3 ratio, option D. Simple balancing of the equation, that's all. Do the balancing of equation, that's all. And if possible, try. Suppose it is 4 liter oxygen. How much CO, how much CO2? Try to get it. Next. See, 5 liter is 1:3 ratio. Suppose it is again oxygen reducing, how much you get? Find out. Next. Supersonic jet planes contribute to ozone depletion. NO. Supersonic jet planes releasing NO gas, which will be greatly affecting ozone because NO will react with the ozone. SO2, NO2 cause pollution by increasing acidity of rainwater. SO2 will produce sulfuric acid. NO2 will cause production of nitric acid. So formation of sulfuric acid and nitric acid is finally governed by or influenced by the formation of SO2 and NO2. Acid rain. Acid rain. Next. Greenhouse gas among the following. All are greenhouse gases. All are greenhouse gases. CO2, methane, ozone, CFC. They're all greenhouse gases. Next. Some of the non-greenhouse gases are chlorine, oxygen, nitrogen, sulfur dioxide. Earlier we had a talk. Next. A good herbicide. Refer NCERT, sodium chlorate, commented as a herbicide. Refer NCERT, sodium chlorate, sodium arsenite, referred in the textbook as an example for herbicide. Next. A secondary pollutant, PAN, described chemically as, see, PAN is peroxyacetyl nitrate. Peroxyacetyl nitrate, that is PAN. This is the structure of PAN, CH3COONO2. This is peroxyacetyl nitrate. It can be considered as a mixed anhydride. You see, COO, that is peroxy, mixed anhydride. It can be considered as a mixed anhydride. According to the class of chemical, it may be called as a mixed anhydride. Next, answer is option D. 250 gram toothpaste has 1 milligram fluoride content. Concentration in ppm. ppm is milligram per liter or milligram per kg. ppm is milligram per liter, or it may be milligram per kg. It is given 1 milligram, 250 gram, 1 mg in 250 gram. Therefore, how much mg in 1000 gram? That is 1 kg. That is ppm. It will be 4 times 4 ppm. Option A. Option A, 4 ppm. 1 milligram in 250 gram. So how much in 1000 gram? That is milligram per kg. That is ppm. 4 times. Next. Minamata disease related to mercury poisoning, methyl mercury poisoning. The disaster happened in Japan, known after the concerned river, Minamata River, on the shore of which this industrial disaster happened, in the form of methyl mercury contaminating in the river, affecting people indirectly through fishes. That is Minamata syndrome. Minamata syndrome. Methyl mercury was the chemical involved. Mercury poisoning. Some of the green chemistry developments. The last portion of the particular chapter dealing with the green chemistry applications. And I think all are referred there in the textbook you can find. And the answer is all these. Replacing chloroethene as a solvent, replacing chlorine by H2O2 in bleaching process, replacing multi-step synthesis. This is one example given there. Answer is all these. All these. Next. Once again, the limiting content values. That seems to be a repeating question, but not the exact same. The limiting content value of the various polluting components. The answer is option C. Option C. 1D. Iron D, Aluminium. I think here there is a missing happened. Here there is a missing happened that you can cross check. 3B, copper B, 3 ppm and 4A, zinc 5 ppm. Right? That's a table given in the textbook. You can easily verify the threshold limiting value of various components reported in the NCERT. Next. The ion which in small amount necessary for the healthy teeth, but higher concern, fluoride, because apatite family compound, fluoride, is essentially required for the tooth enamel strength related activities, the biological changes concerned, but the higher concentration will cause mottling of teeth. Fluoride ion concentration on a higher quantity will cause mottling of teeth. Answer is option C. Next. The chemical involved in DDT preparation are all these. We need chlorobenzene, chloral and concentrated sulfuric acid. You see that this is chloral. CCl3CHO. I will write in the structural identity. CCl3CHO interact with 2 molecules of chlorobenzene. It interact with 2 molecules of chlorobenzene and it undergo condensation with the sulfuric acid. It will be condensing like this. The water molecule out and you get DDT. This is what DDT. Some of you definitely might have seen the structure, remembering the structure. This is what the structural entity so called DDT. Dichloro, diphenyl, trichloroethane, polychlorinated biphenyl, PCBs are. Dichloro, diphenyl, trichloroethane, DDT. Next. Prions are, all are true. Prions are non-toxic, used in refrigerators, non-inflammable, but their level when increases and reaches to the stratospheric region, and once it is undergoing a homolytic fission, it creates the issue. Otherwise, it is unreactive, non-toxic, no issues at all. Wrong statement regarding classical smog. Option A correct. Option B correct. Option C correct. Option D is the wrong statement. It is not containing PAN. Pan peroxyacetyl nitrate is a component present in photochemical smog, not in classical smog. So classical smog, all other statements are true. The last statement is wrong. PAN is present in photochemical smog. Okay. Photochemical smog is characterized by all the above. All these are characteristics of photochemical smog. All these are characteristics of photochemical smog. So classical smog is reducing in nature. Photochemical smog is oxidizing in nature. Okay, next. The harmful effect of acid rain include corrosion of metal water pipes, yes. Leaching of heavy metals such as iron, lead, copper, etc. Yes. Increasing the soil pH. No, it will actually cause a decrease in the soil pH. It will actually cause a decrease in the soil pH. Answer is option D. All except C. C is wrongly given. It is not actually causing a increase in pH. It is actually causing a decrease in pH. Okay. Answer is option D. The rain is described as acid rain if the pH is, see, normal pH of rainwater is, normal rainwater pH is 5.6. Acid rain means it will be less than 5.6. So the answer is option D, 4.6. Or coming to 4, 3, that is strongly acid rain. This is normal rainwater. A gas that gets instantly oxidized further by air is NO. NO will be instantly oxidized. That's how it becomes toxic or acting, giving vigorous reaction. In a bottle, if you take NO and just open it, it comes out as NO2. It comes out as NO2. It is instantaneously converted to NO2. Substance not found in the stratosphere. Water vapor. Water vapor normally not found in stratosphere. Problem caused by photochemical smog include all are threat of photochemical smog and referred detailed in the textbook. Powerful eye irritation, cracking of rubber insulation, irritation of nose and throat. Yes? Yes. All are the consequences of photochemical smog. Right? So that is a few questions from, as I said, a small chapter, a simple chapter from the 11th standard topic, last chapter of 11th standard topic. We will meet with another chapter in another session with some beautiful questions. Until then, bye. See you.